Hello and welcome. Today we are going to build a machine learning prediction model to be able to identify fraudulent transactions on a given dataset.
So once
Let's
we
get
import
dive
the
into it.
libraries, the next thing we want to do is to call our actual CSV file. So I want to call my dataset as df. Df equals to pd pandas library read underscore CSV to be able to see our um, CSV file here. Okay, so will work here. I think that was a little typo. So df dot head is going to give us the first 5 values of our actual data set named as df. While it's processing, just um, type that down. So hopefully we're going to get first 5. Yeah, there you go. From 0 as an index to 4, so giving us the 5 values. When we put inside here 7, it's going to give us the first 7 values of our data frame. So here is the just basic table. The first thing I realize is the type is listed as an object. It's not numeric, so we might need to transform into a numeric value. The others are name origination, also here probably typed as origination, also not numeric at all. And the others might be float or integer. We can find out soon. But the one thing I want to show, there is fraud column is what we target here, so it should be in integer format. The 0 is, I think, non-fraudulent, so it's there is no bad transaction happening here, but the 1 is actual fraudulent, what we target. So let's go. So the 0 is legitimate, obviously 1 is fraudulent. So I want to see the data frames shape. The shape is going to give us all rows. We have over 6.3 million rows, and there is 11 columns in our data set. Also wanted to see and confirm the types here, what sort of format we have. Again, the type column, we have all the payment types listed up as an object. Is fraud integer? At the moment I think this is all good, but we might need to again label encode object. There's two methods, one called one hot encoder, the other one label encoder. We will need to go with object values here, label encoder, because I think there's more than 3 types, not 2 types. And also I want to see if there's any null values. df dot is null and some. There is no null values, good thing. We don't need to eliminate all the null values, but I want to drop duplicates if there's any, just in case. In place true. Yeah, while it is processing, also one last thing I want to show here. df.describe is going to give us all the table. It has been processed. Yeah, describe is like all over the place. It's putting a column next to each other and first 5 rows and last 5 rows. But we can also go with df.describe with parentheses. It's a pretty much very pretty format of describe with parentheses. It's looking much better. But now we get also mean values, standard deviation, minimum 25, 50, 75%, and maximum values here. And next thing, exploratory data analysis. I want to explore our data with and visualize it if necessary to be able to find out the values better. One thing I want to target maybe here is the object value here type, because I don't know how many transactions happened as payment, cash out, transfer, or if there's any other ones. So let's get down to here and maybe just call type and count value counts and have a look into that. Yeah, there is cash out, payment, cash in, transfer, debit, um, five different objects here, rows here. So it's pretty much it about value type, and maybe we can visualize it because it's not looking so good. Let me go with plt.py. It's maybe I can call it as a name type underscore counts equals to, yeah, type underscore counts, and let's go with plt dot show. Yeah, it's not looking very pretty. We don't really understand what's in there. What we need to do is to put the labels type underscore counts dot by index, of course, and let's see, we can see now, and we want to see the percentage as well. It's better to have percentages, PCT and percentage 1.1, F percentage, hope that works. Yeah, there you go. So yeah, cash out is 35% and followed by payment around 34%, very similar, but very least transactions, 0.7% is debit. It was another thing. We can also try to find out the fraudulent transaction, number of fraudulent and legitimate transactions. Let's call this fraud counts. Df is fraud, obviously, and dot value underscore counts, and then we'll of course call it print fraud underscore counts. There you go, we got over 6.3 million, almost all of them legitimate transactions, only 7,000 transactions are fraudulent. And now we can maybe analyze it in another pie chart, but I just want to go ahead with maybe setting them up as a beautiful format in describe. So what we can do is pd.set underscore option display dot format underscore, should be actually float underscore format, and then we can put in here to F, and shouldn't be one here, and then format, and df dot describe. Yeah, we can see now the actual formats, actual numbers, instead of here a little bit of complex, better visualize it. And next thing, maybe we can go ahead with the correlation between the columns, which is very generic, df.core, just in case numeric underscore only, I will set as a true. Numeric true. Yes, so we can see the correlation between the columns here, but we may need to also show in a heat map so that we can better visualize it with Seaborn library. SNS.heatmap. So we will pass the correlation number up here, numeric underscore only is gonna be true, and then annotations true, and then CMap, I want to visualize it as a with the cool word format. Let's see how we go with this one. Yeah, there you go, but yeah, that's not looking very good. We can also do that. PLT dot figure is gonna give us to be able to make it bigger. This is the one we should go. So let's go with 12 to 10. Fixed size equals to PLT. There you go, much better. So we can see the correlations between the columns here. Obviously, near balance origination and all balance origination is correlates 100%. But we're now able to see some other thing, near balance destination amount, which makes sense. There's all balance destination also correlates with amounts, which also pretty much makes sense. And there's some negative correlations, but not really huge, 0.0005. So yeah, well, this is what we expect actually with the amount correlating with old balance, new balance destinations, and all the others. Now we can get down to maybe future engineering. So we will need to do, as we mentioned here, the types to be listed up as integer format for our modeling to work. This is the main performance thing. You should either go with one-hot encoding, but since we got 5 different types, we will need to select label encoder here. So from Scikit-learn, I'm not sure if I import that previously, processing import label encoder. So encoder is going to be an empty dictionary, and we will need to fill that in with the selected objects, the types for each object. It will map our objects into that encoder, and encoder is going to transform them into integer format. So encoder is I is going to be labeled encoder, and let's fill that in with encoder I dot fit underscore transform EFI for another typo, and processing another typo. Hope it's not gonna throw any errors this time. So we are creating a categorical new future, which is going to be integer again. Let me also, once it does with the processing, once it's done with the processing, we can now see the types label encoded. So these new features can be useful for our models that might perform better with categorical data, or maybe need to recognize patterns across different groups. Still processing it. Next thing we will do is to split data into X and Y. While it's completing its process, let me also go ahead with the data split. So our actual target is fraud, so the X will be is fraud, and Y will be also the actual X fraud, so that we will be able to test it out and then train and test it out. Now we can see that all the types are label encoded 1 to 4, and fraud is our target again. So we put X, the is fraud column into X. Actually, I'm sorry, we just dropped is fraud from our table and put them into X, and Y is gonna be our target. It is fraud. We process that more, and let's go and check Y underscore value counts. Yeah, it works. But one thing we need to also get rid of is to equalize them, because there is a bit of imbalance, huge imbalance here. To be able to better train our model, it needs to be the same amount. So we already maybe imported again. I wanted to import just to make sure, or let's go up here. Yeah, we have already imported smooth with imbalance, and we just maybe do sample here and smooth random state as always 42, and what we need to do is to place this oversample into X and Y and fit that in, resample X and Y, and lastly I'll need to confirm it if it works. Value underscore count. There you go. Now all equalized. We also can avoid the imbalance between these two.